Hello. We're going to talk about more about light. Okay. So in optics, we talk about light behave like rays. So let's elaborate a little bit about rays. So we have a light source, like a candle, right? So the lights actually will go out in 360 degrees. Okay, so this is 360 degrees. So what are we drawing? We are drawing rays, right? We call that rays. But really, this ray is 90 degree, right? Ray is 90 degree to the wavefront. So what wavefront are we talking about? So we are saying that this light, so this is the source of the light, right? This is the light source right here. So when it goes out like this, right? Like that. Okay, well, I'm drawing, it should be like that, but I have to draw it like this, okay, in order for us to see it, right? So then you actually have this wave that's going out, right? The wave that's going out like that. Okay, so you have wave that going out like that. All right, so it's going out like that. So light, right? It's wave-like, right? It's wave-like. Okay, so it's the wave, right? But what we draw is the ray, which is 90 degree to the wavefront. So what are we talking about? Let's try one more time. So this is the wavefront that we're talking about here, right? Okay, so let's say if I draw the plane case, okay? Let's say you have one wave like that, and then another wave, right? And there are lots of them. So this is your wavefront right there, okay? And that's your wavefront right there. So this is your crest, right? That point is your crest. And this is your crest also, right? And this is your trough, right? That's your trough. Trough. And that's your trough, right? Well, you can also say this is your wavefront, okay, if you like, right? But this is one of the wavefront. So when we say this is a wavefront, we are drawing this, okay? So this is another wavefront right there. Okay, so this is so-called a wavefront, right? So wavefront is propagating out. And the ray, when we draw ray, we draw in 90 degree to it, right? So we draw in 90 degree to the wavefront. You see that? We say the ray, the light is going out this way. But light can also be going out like that, right? Can also be going out like this wavefront going out like that, right? Okay. And it can also be going out like, remember the EM wave, right? We draw the EM wave that, this is the E, and then we have the magnetic field, right? It goes like that, right? And then we have the velocity going this way, right? And the energy going that way too. So there's a many different way of representing light, okay? So we are talking about the different version of it. Okay, and it's still controversial. All right. So now we're going to talk about another behavior of light. So light can behave like it can interference, which we learned in AP Physics 1. So interference, it can be constructive, and it could be destructive. Right. So in Chinese, this is 建设性, right? And this is 破坏性. Okay, and this is called 干涉, right? All right. So this is based on the principle of superposition. So what are we talking about? So let's say if you go to the pool, I think I've asked students in the past to do this in the pool, or like in the lake, right? You have two tennis balls. These are tennis ball, right? Now you start bouncing it, right? Bouncing it, create a wave, the water wave, right? So the water wave can behave like light wave in a sense. So then the wavefront will go out, right? The wavefront will go out. Okay, one more. Not very good, okay? All right, and then on this side, we have wavefront that's going out. I wish I can do better. Okay, and then the black one. Okay, and let's take a look, right? So this is the crest we're saying, the peak, right? And in the middle, this is the trough or the valley, right? So in the middle, this is the trough or the valley. So the low point, right? Same thing here, right? This is the valley, right? The valley. All the troughs, T-R-O-U-G-H. Okay, and that's the crest or peak, right? Okay, so let's take a look. So this one is the peak meets the peak, right? So that one is constructive. So we're going to put a C right there, right? And let's take a look at this one here, that point. Okay, I'm changing color here to green. You can see this one here, this is P, but right there is in the middle, right there. This one here is destructive. I put a D right there, okay? And then right here is another C, right? Right there. It's another C right there. Another C right there, right? It's all C, 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 right? Okay? Yeah. So then they will, let's say if you have this, we studied this before, right? You have one and you have another one that's same phase, right? Then together they will become bigger, right? Bigger in amplitude. Okay, so they will add together and then become like that. Okay, so this would do the same thing. They would interfere and they will add, they will overlap, they will add. And right here, they will cancel each other, right? So if you have this, then you have this, and it's out of phase, so then this peak will meet the valley. And the valley will meet the peak, right? So then they will cancel out when you add these two together, it becomes like that, right? If they really cancel out, right? So this is so-called interference. So constructive and destructive. Let's do a little more in the destructive side. So you have destructive right there, right? You have destructive right there, destructive right there. Okay, and it's more destructive right there. Yeah. Okay. Right. So well, it can be a lot more organized but I can't do it right now. Right. So that's what we have, so-called interference. And then there's another behavior which is described by Huygen's principle. And someone say this is called Huygen. No, I can't even pronounce it. Huygen's principle. So this one here is really useful in diffraction. So diffraction is a 绕射. So lights can do many different things, right? So light can do deflection, 反射, right? Okay, and light can do refraction, 折射, right? Which we have studied. And light can do diffraction or diffraction, different pronunciation, right? So we're going to talk about this one right now, right? We already talked about this one already. So what's diffraction, right? So if we say this is the wavefront, okay, plane wavefront, it's coming in, okay? All of a sudden, there's an obstacle right there. Let's say there's a wall, and then there's a little opening right there. And the size of this has to be small, okay? This D is close to the lambda, okay? The lambda of this plane wave. So the wavelength of the plane wave. Okay, and keep in mind this means that we have this, right? Okay, we have this, all this is going. And if you want to draw the ray, then you would join like this. That's your ray right there. So the ray is coming in. Okay, but ray model is not really useful in this kind of diffraction situation. Okay, because all it would say is the ray will come in here and it will keep going straight, right? But that's not what the light actually do. When your D, this opening, is very close to the wavelength of this plane wave. Okay, this is called the plane wave. Okay, so it would not do this. Instead, it would do something else. So let me erase this and then introduce a little bit of that, and it will be done. So we're here, and this is kind of like an obstacle right there. So like a wall, but with an opening, right? There's an opening, little opening right there. Opening. A small one, okay? And so your wave is coming in, the wavefront, right? This is the wavefront. So what it would do is that it would actually come here, and then it would start to behave like you have this, all this different light source, okay? I mean, I can only pick two in there, and it would start to do this kind of things. So it's like there's not a wave source. That's not a new light source, right? New light source. Okay, remember this one is from a light source very far away and then later become a plane wave, right? So right here, it becomes a spherical wave again. So this new dots right there can behave like it's a new light source, okay? New light source. And that one then will start to create something like that. Okay, so then we'll go out. And so basically it will behave like the light comes here. When it sees the obstacle like that, it actually goes around it in many different directions, right? Remember the refraction is like the ray comes in and then it change direction, it bend it, right? But it's only one direction. But diffraction is not. Diffraction goes, the ray goes this way, the ray goes this way, the ray goes this way, the ray goes this way. So that's called diffraction, okay? And this is based on this new light source, and this ideal new light source is the Huygens principle, or Huygens principle. Which basically says that the wavefront, every single point can behave like a new source, right? So every point can act as a new spherical light source. All right, so that's the Huygens principle. So we're going to stop there, yeah, and let's just wait until next one, okay? And bye-bye now.